Hi, we are going to start stoichiometry with mole-to-mole stoichiometry. These are your notes, so make sure you do them with me. What is the definition of a mole ratio? Well, it's the ratio using coefficients from the balanced equation. So that probably doesn't make much sense to you. Let's start from the beginning. First of all, our last review was on one substance conversions, okay? That's this side. If you got it from me, you can flip it over. Otherwise, if you printed it out, you have our stoichiometry mole island. This is between two substances, which means there is a reaction, okay? We have substance A and substance B. We can figure out the moles of substance A, and we can convert to how much moles of substance B we need or we're going to produce, and we do that by using the coefficients from the balanced equation, which is our mole ratio. And this is what our lesson is going to be on today. So make sure you understand that this is used between two different substances. This conversion is just converting one substance. So if I have so many grams of oxygen, how many moles of oxygen would it be? Okay, so we are going to start by thinking about our reactions. Let's say that I have hydrogen plus oxygen, and that is going to make water. So how many hydrogens make how many waters? Well, this is a recipe. We have two hydrogens and it makes two waters. Okay? In order to make that, I also need one oxygen. So I have two hydrogens and one oxygen. Notice I have double the hydrogens there are to oxygens. Well, how do I know that? I have 2 moles versus 1 mole. That's our coefficients. If there's nothing there, you can always assume there's a 1. So let's step back and think about this. This is just a recipe, okay? So here's our recipe. We have 2 eggs and 1 cup of flour, and that's going to make 4 really yucky pancakes. But it will do that. So this is our recipe. How do I know how many pancakes I'm going to make? Well, I have to put in the right amount of ingredients, and this is 2 eggs and 1 cup of flour, okay? Now, sometimes I want to double and triple the recipe. So let's double the recipe. Here I would use 4 eggs. And if I have 2 eggs, it'll make 4 pancakes. If I double my 2 eggs to 4 eggs, it should make 8 pancakes. I just doubled that again. Okay? And how much flour do I need to make it? Well, here I doubled everything, so I could say 2 cups of flour. That would be doubling it. Or I could also say that here I need half as much flour as I do eggs. I have 2 eggs and 1 cup of flour. 1 is a half, so I just took half that amount. And then I'm going to get my 8 pancakes. What if now notice my recipe never changes. If I double or triple a recipe, that's something I have to do in my head. They don't give me that on the back of a box. But I can do all that in my head. So this was times 2. So I took everything times 2. Okay? But what if I want to do it times 3? Then I could make everything times 3. Now I'm going to do this a little backwards. So if I want to triple the recipe, and this one's gone now. If I want to triple the recipe, that means I'm going to make 12 pancakes. In order to make 12 pancakes, how much flour do I need? Well, we tripled the recipe. So that would be 3 cups of flour. Now, we can look that this is 1/4, 4 to 1. This is 1/4 the amount, and this is 1/4 the amount. So these are how I can figure out ratios. Okay, now I could triple the eggs, and that would give me 6 eggs, or 6 eggs. Or I can look at my ratios. For every 1 cup of flour, I need 2 eggs. That means I need double the amount of eggs. 3 cups of flour, I have double the amount of eggs. So there's 2 ways to look at it, okay? So this should all make sense to you. Our mole ratios is just a mathematical way to get to this. So let's look at what's going on here. And we're going to use our triple the recipe, okay? And we are going to say that I start out with 6 eggs, okay? And then I want to know how many pancakes. Cakes. And I'm just going to put this on the side. We know that was 12 pancakes, right? Pancakes. So this is our mole ratio, and our ratio is just like our conversions. I start with 6 eggs, okay? Whoop, whoop, whoop. I don't want to know how many eggs anymore, so I put my eggs on the bottom, and my question mark where I'm going to is pancakes. Pancakes. And here's where the mole ratio comes in. What is true between pancakes and eggs? I have to look at my recipe. For every 4 pancakes, I have 2 eggs. Okay, and then if you put that in your calculator, that will give you 12 pancakes. So hopefully you can see when I triple the recipe, that made sense in our head, right? But we need to do that faster because it's not always going to be perfectly even. I might have 0.28 eggs, and then things get a little complicated. So we're going to use our mole ratios, which comes from the coefficients of the balanced equations. Okay, so let's go back to our notes before we work on this part. And we are using the coefficients from the balanced equation. That's what a mole ratio is. And let's interpret what this means, because we can say we have 2 molecules of water and 1 molecule of oxygen makes 2 molecules of water. Or, you remember, we don't count by molecules. They're way too small. So we need to count by moles, right? Our moles are our packages of 6.02 times 10 to the 23rd. And that way we can weigh that or count that. So instead of molecules, this could also mean moles. Remember, instead of having one water, 2 waters, 1 oxygen, 2 hydrogen peroxides, we could have 2 dozen, 1 dozen, 2 dozen, or 2 mole, 1 mole, 2 moles. So this doesn't make water. It makes hydrogen peroxide, sorry. There we go. So 2 moles of water plus 1 mole of oxygen makes 2 moles of hydrogen peroxide. Okay, that's what our recipe says. All we did was multiply it by moles. Okay, so our mole ratios are those conversion factors that we use. Hydrogen peroxide to oxygen, that's a 2 to 1 mole ratio. Okay, I put 2 to 1 there, or you could write it equals a 2 to 1 mole ratio there. Okay, so this mole ratio could be anything we need. Maybe we're not going to hydrogen peroxide. Maybe we want to know how much oxygen we need. Then we can do oxygen to H2O2, and that would give me a 1 to 2 ratio. It's just flipped. Here we have double the hydrogen peroxide that we do oxygen, Here we have half, 1 to 2. Half the oxygen is hydrogen peroxide, 2 to 1. Okay, so you guys can make up anything you want here. We can do O2 to H2O, and from my balanced equation, that's a 2 to 1, 1 to 2. So it goes 1 to 2, and you guys can make up your fourth one. It doesn't matter which one it is. You can flip it. These are just mole ratios that we use to convert. Okay? So, let's go back to our problem. This one we're making water, and remember this is, if you don't see it, that's a 1. And let's say I want to double my recipe. So if I have 4 hydrogens, how much water will I make? Well, if I have 2 hydrogens, I make 2 waters. If I have 4 hydrogens, I'm going to make 4 waters. But you need to be able to do this using mole ratios. So what did they give me? They gave me 4 hydrogens, and we didn't know how much. We wanted to figure this out. That's our question mark. We write down our given hydrogens. Do I want hydrogens? Am I figuring that out? Nope. So let's get rid of it. And I'm looking for moles of water. Okay, so that's H2O. And I could put moles all over here, but these 2 moles and my mole ratio cancel out. So I never write them in a mole ratio. And I'm left with 4 moles of hydrogen. Okay, and what's our ratio? It's a 2 to 2. That just equals 1, right? So that equals 4 moles of water. My hydrogen moles cross out, my hydrogen moles cross out. I'm left with moles of water. So this is our mole ratio. This is our stoichiometry, and basically this is the heart of stoichiometry. What I've just taught you is how to use our stoichiometry map and go from moles of substance A to moles of substance B. Now notice, all this, you've already done this. So if they don't give us moles and they give us grams, we need to convert to moles so we can do our mole to mole ratio. If they don't ask us how many moles is left, they ask us how many grams are left. Well, we still have to convert moles to moles, and then we can do the one substance conversion between moles and grams. And this is basically our unit. We will do percent yield at the end, but we're just going to learn how to go through this map. And it's all going to be ratios. Get rid of what you have on the bottom. Go to the island you're going to on top. Okay, so if you follow this map, however they ask you to go, you're not going to have a problem. Okay, let's go back to our notes. So I have a sample problem here. How many moles of oxygen do I need in order to produce 17.6 moles of H2O2? The first thing I have to do is start with a balanced equation. Yes, you have to balance the equations because balancing changes those coefficients, and that is your correct mole ratio. So I have 2 waters plus an oxygen makes 2 hydrogen peroxides. Okay, so you guys should be able to balance it, but it was the problem that we were just working on, so I knew it. And now we are going to ID, and this is on a fixed worksheet. Number 2 is ID. So they gave us 17.6 moles of H2O2. Notice when you ID it, you put it right under what you need, and I need to know what is the measure because you're not always going to find moles. You'll always have to go to moles, but you might be converting it to grams, but we'll see that in another lesson. How many moles of oxygen do I need to do that? Okay, now write down your given number. That's 17.6 moles of H2O2. We are going to convert. And notice a one-step conversion. I'm just going from one island to another. That's just one step. Okay, so 17.6 moles of H2O2 Do I want moles of H2O2? No. Where do I put it? I put it on the bottom. Why? Because then these cancel out. And what am I going to? Question mark. They asked me for moles. How many moles of oxygen gas do I need? Now, some people want to put the 17.6 down here. Remember, that does not go down there. It's what is my true statement. And if you forget, right here, whoop, whoop, coefficients from the balanced equation. So my coefficient for oxygen right here, if there's nothing there, you assume it's a 1. And H2O2, my coefficient right there is a 2. So this would be 17.6 divided by 2 in your calculator, okay? And then hit equals. Why? Because we multiply by that, we divide by the bottom. And I am left with, let's figure this out, double checking your calculator with me so you know you don't have a calculator problem. Many, many people do. I have 8.8 moles of oxygen gas. That's what's left. That's what's not crossed out. Now, I have 1, 2, 3 sig figs, and I only have 2 sig figs there, so I'm going to write 8.80 moles is my measure, and oxygen gas is my chemical. You have 2 things to check for your units, okay? Okay, so guided practice. Can you do this one yourself? Pause your video and see if you can. Okay, first thing I do is I write down my balanced equation, and that's still going to go with the same reaction. So I have 2H2O plus an oxygen is going to make 2 moles of hydrogen peroxide. How many moles of water do I need? I'm asked to find water in moles, so I write it right underneath. Okay, how many moles of water do I need to react with 7.2 moles of oxygen gas? So notice, this is a perfect ratio. You're going to see some problems that say with plenty of something to react. That just means you have enough, it will completely react. And we're not going to go into limiting reactants. But let's start. I write down my given, 7.2 moles of oxygen. And because we're going through 2 different chemicals, it's important to make sure you have that. Okay, I don't want oxygen gas anymore. Moles of O2. I want moles of H2O. Okay, so moles of H2O, that's a 2 from the coefficients from the balanced equation. That's what goes into this conversion factor to 1. Okay, so that would be 14.4 moles of, cross that out, what do I have left? Moles of water, and that's what they asked me for. Last step, significant figures. I only have 2 here. 1, 2. Does the 4 round it? No, it doesn't. So I have 14 moles of water. Okay? Now, you can do all this on a piece of paper and send me a picture. But I do have an easy way down here to show you. So here is my first problem, okay? Now you have to balance this equation or it will be wrong. 1 magnesium, 2 bromines, 2 bromines, 2 chlorines, 2 chlorines. Woo, we're good. We don't have to balance that one. And then I should ID. They give me 0.25 moles of magnesium bromide, and they want to know how many moles of chlorine I need to react completely. Okay, so I write down my given. I get rid of my moles of bromine. I go to moles of chlorine. My mole ratio is 1:1 plugged in from my balanced equation. Okay, and then what is my answer? Well, it's 0.25 moles of chlorine. Okay, you need everything here. You need your answer with the correct units. Now, this is how it makes it very easy to see what gets crossed out. However, typing this in like this can be a pain. So I've showed you how to type it in on one line. This is 2 moles of magnesium bromide. And notice I didn't subscript that, and that's fine. And my mole ratio is 1 mole of chlorine to 1 mole, here's my little slash, 1 mole of magnesium bromide. So you could write it shortcut like that, right in there, and then make sure you have that with your answer, okay? So now, our next problem. We start with 0.30 moles of aluminum, okay? And excess iron. That means this is going to react completely. Remember, if I didn't have enough to react with it, I wouldn't make the exact same amount. So this just says excess. That means we don't care about that. How many moles of iron can be produced? Question mark, moles. I've ID'd it. Now I have to see if we're balanced. Okay, so my aluminum, I needed 2 there. My iron, got 1 iron, and my oxygen's 3 here, so my oxygen has to be 3 here. What did that change? That changed my iron, so that has to be a 3. And now, double check again. I have 2 aluminums there, I've got 2 aluminums there. I've got 3 irons there, I've got 3 irons there, I've got 3 oxygens there, I've got 3 oxygens there. We're good. Now, how do I set this up? I write down my given, 3 moles of aluminum. I do not want moles of aluminum, so I put it on the bottom so they'll cross out. And I do want moles of iron. And now I need to plug in these numbers. Where do I get them? Not from here. Do not use your given there, okay? That's a common mistake I see. This comes from coefficients from your balanced equation. So, balanced, 3, aluminum, 2, and now you can see that balancing becomes really important, right? So, 0.3 times 3 is 0.9 divided by 2 should be 0.45 moles of iron, and that would be my answer with units, and you'll have a line to put that there. Okay, now for number 3, if you are still confused on this, this is another lady. It's a short 4-minute video. I am going to link these like I always have before on your Google Classroom. There's a couple of people, not many, there's 2 to be exact, that have our school computers and they're blocking them when it's on my worksheet. So they will be attached like they always are, but if these links work for you, this is faster, right? You just click on there. 4-minute video, and the second problem will go over this problem with you.